Hello everyone, I'm Larry from Fix. Today we will talk about the A12 CPU in this lesson using iPhone XS Max. Next, learn about CPU measurement. Switch computer screen. Please observe the schematic. See the first C1853, which is the 1.8 power supply for the RAM. Second line, the C1843, that is the 1.1 voltage power supply for the RAM. Third line, the PP0.8 SoC, that is the capacitor C2753. Fourth line, that is the C1391, is the 1.2 voltage of SoC power supply. Fifth line, C2712, one power supply line for GPU. Sixth line, the C2782 is the GPU SDRAM, which is also a power supply for the RAM. Seventh line, the C2811, that is the PP CPU E-core. Eighth line, test this point, the C2700. The last one, power supply of the PP CPU SDRAM, that is the C2733. Switch screen. Next, test whether today's motherboard can boot. The lens test in the lower right corner. Now I use the iPhone X screen because there is no Max screen here. So we can't measure the touch. Test the display today to see if we can go in. See if this motherboard is working properly. Okay, there are white apple displayed. See if you can enter the page. The hello interface, which can enter the page. Because we use the iPhone X screen, we cannot measure the touch. So let's go to see this hello interface. Next, layer it and handle the CPU. Use this PCB holder. The hot air gun without nozzle. Temperature 330, wind speed 30. Layer it. Use a pair of tweezers for layering. The hot air gun without nozzle to blow. Remember to rotate. Before blowing, we remove this sponge. You can take it or not, it has no effect on us. Just beautify it when you install it. We continue to blow. When blowing, you can put the tweezers in the middle and wait. If you can insert it, you can separate the middle layer. When you see bubbles popping up, you can separate the middle layer. At this time, it can be separated soon. Tweezers inserted. Then you can pick this up and put it on the PCB holder. This is already layering. Remove the thermal paste after separation. After that, operate under the microscope. The first step is to remove the glue. This blade is used for removing glue. To remove the glue, use this 6mm air gun nozzle. Temperature 320, wind speed 30. Remove this glue. A12 glue is softer than other models. The glue is softer than iPhone A11, A10 glue, so it is easier to cut. But there are two glass chips here. Keep the glass chip safety. Be careful of the resistor next to the edge glue. Many resistors are useful. This side is the most difficult because there are two glass chip audio IC. If one of the audio is broken, it may not work, so be careful on both sides. You can remove the glue away from the IC, and then remove the glue next to the IC. Be careful here. We'd rather not cut it all off or hurt the IC. Don't cut the audio IC to the bottom, because the cut may squeeze the audio IC to damage. It cannot be working normal if the audio IC is damaged. Okay, at this time, the edge glue is removed. In these two IC glue do not need to be cut to the bottom. Just split the upper part a little, and prying the CPU will not bring up the audio IC. Next, choose a suitable entrance for prying CPU. Let's take a look at the choice of entrance. Both entrances can be chosen. This entrance needs to be lift these two components off for making the entrance. This side also. Try to select the middle side to making entrance. The protection of the CPU prying will be better. Remove these two capacitors before prying. These capacitors can be removed directly. After this removal, we can pry the CPU. Operate under the microscope. The A12 CPU and A11 are the same. You cannot use the hot air gun without nozzle to blow, because the CPU is nearby. Only use the small nozzle to hit the CPU. This will not let the PMU get problems. Safe. We use this blade. Temperature 390, wind speed 40. Small nozzle 6mm with air gun. This position is the entrance, the position where the capacitor was just pried off. First, hit the CPU. The blade is ready. If we can insert it, insert it. First, hit the CPU evenly. Put the blade in the position and wait for it to melt before inserting. Don't use force first, just put it here. Wait until it is heated, then go inside. We can move hand faster, and four sides must be heated. At this time, the blade can enter. We are ready to insert it a little bit. Insert a little more. It can be inserted. Raise the blade. This CPU is up. At this time, the pad is hit, so quickly process the pad first. See how it pries. Because these two capacitors were removed by us, we will have our entrance. With the little thread upward, CPU will be lifted up by us when the thin ball melts. Handle the pad while it is hot. Because the pad has heat, it will be more convenient for us to handle. First, add 183 tin. Then use a small cover head of the soldering iron. Add some flux and replace the original tin. First, let each solder joint get 183 tin. After replacing this tin, the point of dropping is almost non-existent. If it is original tin, it has a higher melting point and the ergon and soldering iron hard to melt it. Easy to dropping point when cleaning. Don't rush off after changing the tin. If there is glue, use a small cover head to shovel it in, and the glue will be removed. Just move like this. Clean the glue. The same way in the middle to clean glue. A12 glue is relatively soft and easy to remove. The glue in the middle has basically been removed. Clean the glue in 4 edges. Pay attention to the edge. Don't shovel the resistors. Clean this side. After shoveling, you can use the solder wick. Use this solder wick to clean. Clean the solder joints first. The glue can also be removed during this process, so that the solder joints are also fast. Clean it easily in this step. This step does not need to be too clean. Because we will clean the glue next to it. After this step, use the number 11 or 16 blade. This one is the number 16 blade. Temperature 320, wind speed 30. There are two kinds of blade to choose in this step. Number 11 or number 16 blade can be used. We use number 11 blade to clean it. Scrape off the glue next to it. The surrounding glue should be removed with the tip of the blade. But it cannot be too strong. It will scratch the layer. Just moderate. If the surrounding glue is not cleaned, it will push you and cause the CPU to not install well. Be careful not to scratch off the small resistor. These black resistors are useful. You must be careful when you go to this audio IC part. At this time, the side glue is finished. After the treatment is finished, add some tin again, which will help us to clean more flat. Add some flux and tin again. Why we need to add one more time? Because the original tin at the corners was not changed to 183 tin. Clean for size. After replacing it, take out the solder wick. Cut out the used part. Continue to repeat the action just now to flatten the pad. At this time, after we finish tin, we will take off to be removed flat. If the solder wick is white, use the new part in order to let it be more flat. If the whitening part is used repeatedly, it will be uneven. Use the tip of the solder iron to clean the corner, so that it can be cleaned. It is best to use this small color head of soldering iron. Other color head cannot achieve this effect. For example, in this corner, we use the tip of small color head to hold the solder wick to clean tin. Fold it to clean this corner. Cut off the used part of the solder wick. Clean the corner again. almost like this, and it is ready for cleaning. Wash with cotton balls and wash with PCB water. After cleaning, check if there is any glue residue. Then check if the pad is clean, including where the tin is cleaning. There is still some glue here. Take care of it. These details are so important. Done. After checking, you can use the back of the blade to clean the glue on the glass. Pay attention to using the back of the blade. Clean on the glue on this. This basically won't affect us. If the motherboard is heated, it is better to clean it, and the PCB water will evaporate immediately. Look at the pad again at this time, then install it. You need to check it again before loading. There is no line around this point. It is NC point. You can also compare the schematic to see if it is useful. It is definitely useful to have a line next to the point. If it falls like this, make sure to jumper. Like this, there is no trace next to it, and there are no pins underneath. This is definitely an NC point. These pads are no missing useful point. But if the dropping point like this must be jumper. Like here, it is connected to this plate. This is a useful point. Like this, as long as there is a line connected, it must be useful point. It is also useful point if there are pins on the bottom of the point. Next, after checking the points, then go to measure if there is any short circuit in the lines. Check it now. Red pen grounding, black pen test. Look at the value of this line. This line also has value. 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 This line has also value. This line also has value. This line also has value. This line also has value. It doesn't need to be measured here, but let's measure it. The line next to it is not short circuit. Next, we go to see if the current is normal. Use the DC power meter to see if it will show OCP or turn on with the high current. Turn on and look at this current, 0.01. The previous course said that 0.01, 0.02, and even 0.00 are normal. If the starting current is large or the DC power supply meter shows short circuit, the PMU must be bad. .01 and 0.02 or even 0.00 are normal after iPhone success. As long as the startup is not a large current and not circuit, the basic board bottom can be just as good. At this time, even if the bottom of the board is processed, next step, you can handle the CPU. First, observe the CPU has not dropped pins. Did not find any drops. First, remove the edge glue. Use a number 11 blade to cut. After that, I use the PCB holder to hold it. The first step is to add some 183 tin and add flux to mix. If you don't do this step, remove the glue directly, it is easy to cause a drop point. This step is very important and must be done. Try to make evenly soldered joint, get those 183 tin. Try to make every soldered joints melt with 183 tin. At this time, we can remove the glue. Use this soft CPU blade. Whether it is a soft blade or a large blade. Air gun temperature is 320, wind speed 30. Let's blow with a hot air gun first. When you see the solder joint melts and shine, you can scratch it with a blade in this time. In this way you can clean the glue easily. Be sure to wait for the solder joint to melt before removing it, otherwise it will easily scrape off the pin. Must wait for this tin to melt. For example, this point does not get the 183 tin. If you use too much force, you may cut off this point. We must wait for this tin to melt, and we will scratch out this glue. Because this is a soft blade, it is very safe. Handle this place. If the CPU keeps moving, it can be hauled by the air gun. There is no harm to the CPU if it is pressed for a short time. Continue in another direction. After melting, you can remove the glue. Although this step is very easy, it cannot lack the previous operation. Such as changing the tin, waiting for the tin to melt. These 2 points must be done, otherwise you may fail at this step, drop points or other problems. This drop point and jumper line above A10 are more difficult. Let's clear the 4 sides first. Blow it and clean the glue with a blade. Then shovel off the middle with a blade. It is okay even to do like this. This soft blade is safe, don't worry. Glue the glue anywhere. At this time, the most glue has been removed. There is some tiny glue on it need to be processed. Add 183 tin again. Mix the solder joints after finishing. Use a solder wick after mixing. Cut it into some parts. Use tweezer to hold the solder wick like this. Clip like this. Wait a minute to see my operation. Air gun temperature 320, wind speed 30. After the thin melts, use tweezer to hold the solder wick. Flatten the solder joints of the CPU. Why we need to use the air gun here? Because A11 to A13 are easy to drop points if you use a soldering iron. If you take it off with an air gun, it will not fall. So we need to use an air gun. After the first one is taken off, we will take another one. This can make it more perfect. After clean, wash it with cotton and PCB water. Don't be afraid of heat. The chip is cleaned when it is hot. Because it can make the PCB water evaporate faster. After cleaning, you can see that they are still black. We can carry out cleaning. Blow it to melt first. Then clean the small residues roughly. Treat all the glue you see and clean it. Too thin glue does not need to care for it. As long as it doesn't prevent us from reball, it doesn't interfere with fitting. So don't worry too much about this little glue. This is done. If there is still black on the surface, this will not affect our reball. We don't have to deal with it. If you still deal with it, pay more attention not to hurt the CPU. Now this state does not affect our thin planting. Reball is possible. I saw a ring of glue before planting thin, and I still need to remove it. Clean both sides. Clean this side for reball. After this step, you can plant tin. Getting to this effect, you can plant tin. Take a tissue and fold it under the CPU. This will cushion the tissue and prevent it from bulging. Use this stencil. A12, A11, A10 models are available. We use the most common stencil. First, clean the stencil. Both sides must be clean. After cleaning, use your fingers to bounce off moisture and dirt. Observe whether there are foreign objects under the microscope. If there is still, continue to clean. Wash it again. Don't let the dirt inside. If there is a foreign body, planting tin will not plant well. Check it again. You can plant tin at this time. The tin on the blade has not been dried for too long. Planting need to use this flat blade. With this 183-degree tin. After the tin is taken, press it on the tower paper to absorb moisture. With this effect, tin can be planted. Reball, use this curved twister to press. Curved twisters are ready, then a pair of straight twisters. Then you can start planting tin. First, I like the position with the glass. Found a drop point here. Let's observe. How to check the drop point on this chip. If this is missing, you can go to the schematic to see if the point is useful. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We saw the schematic counting like this. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. You can see that this point is grounded. If the ground point is encountered above A10, like this gray, you can right click to select options, display NC and ground. Blue is NC, gray is ground. These two drop points have no effect. Switch back to the operation screen. Observe. If you encounter the drop points above A10, be sure to cover it with green oil. If it is not covered, the tin will go out, resulting in poor installation. So it must be insulated with green oil. Likely touch a little green oil to cure. Use UV curing light. Cure it. Use a blow gun to blow, curing faster. Because the principle of curing is equivalent to drying with temperature, cure it. You can plant in now. First, I like the position. I like the hole to the middle of the solder joint. Conductive to planting tin, falling tin can immediately fall into the middle. Then use screw twister to press the stencil to the correct position to add the tin. For example, let's wipe here later. After pressing and adding tin, we cannot need to press the twister. Then when you add it, the twister gets stuck here. When you add tin to this corner, the twister moves to this place. Do not lift the twister, just move. Then plant tin from here. You can use your finger to hold it after finishing. Continue to plant tin. At this time, the twister should move forward. Last side. At this time, it is finished. After planting the tin, clean the tin with a clean cloth or paper towel. Press it diagonally with tweezers because it needs to be in a triangular shape with the air gun. Preheat the surrounding before blowing. This time you can start blowing. Tweezers and air gun are triangular. Where does tin melt, where does the air gun follow? Don't hurry up after planting. Check if there are any points that are not welded. Let's see, these points are basically welded too. This point. Here. There is one that is not soldered well. Don't panic at this time. Do some flux here. To blow up this solder joint. Adding some flux has good solderability. At this time we can pick up the stencil, don't worry. You can see there is another spot that is not soldered. We can cover the stencil. Did not check carefully just now. You can be seen under the microscope that this point is not welded. Then add some flux. Blow with air gun. Observe carefully and wait for it to fall. If it falls, it must be welded. It will be obvious if there was no tin falling. It can be seen that the green oil underneath is definitely not going to fall. At this time, you can pick up the stencil. We check it again. Here. There is one more. There is another half here. If this happens, add flux. Flux for the entire CPU. This will ensure 100% tin. After adding the flux, blow again. Blow it again. If the tin don't fall down to the CPU, use this method to save. Every point will be melted with the flux, so be sure to wait. This is the thin ball with green oil. Be sure to remove it, otherwise it will go to other places. Check the solder joints. Every solder joint is welded and the size is uniform, so it is fine. Next, reset it. If the flux was added during the thin planting process, there is no need to add flux again. Direct blow. Reset. Then look at this solder joint. The size of each solder joint is very uniform. Even if this planting is finished. Then you can install it. Be sure to clean the pad before installing. Clean the pad with cotton and PCB water. Install after cleaning. After the PCB water has evaporated, it can be installed. Add a thin layer of rosin. This kind of rosin is okay. Smoke a layer of rosin. Then add some flux. The argon melts the rosin, adding flux around. The characteristic of rosin is sticky. It will be better to put it on the CPU to fix it. We can look at the pin position. See the glass also okay. Just install the glass in these positions. Don't even remember the A1 pin position. I like the position, put it evenly around. After, you put it well. Airgun temperature 380, wind speed 30. Observe carefully when loading. When bubbling, then you can push it. Try to let the force edge size of CPU also get the wind of the air gun. Okay, bubbling at this time. Bubbling means that it has shifted itself. Shifted, we can reset with a light push. After pushing it, we are done. After it is installed, it must be cool. Take out a small fan to cool it. Wait patiently. The heat is almost gone. Take the fan away. Let's first measure whether there are short circuits in those lines just now. If have some short circuit means CPU is not installed well. There is no short circuit is good. No problem with the first line and the second line. No problem with the third line. This one is connected to the last line. No problem with this one. No problem. No problem. No problem. After measuring, you can go to check the current. Look at the current. Let's see if it is the current of the normal boot. Okay, this is the current of normal boot. There is a jump. You can look at the current of this DC power supply and this boot current. Then buckle the screen to test. White Apple interface came out. See if you can enter the Hello interface. The current of this boot is more than 1 volt. Waiting for boot. Okay, the Hello interface come out. You can see that the scratch just now. This is successful. iPhone XS and iPhone XS Max single upper layer can be turned on. The lower layer functions are touch, baseband, Wi-Fi, and FNC and so on. So the display line is on the upper layer. It can be turned on the upper layer. Then today's A12 lesson is completed. See you next time.